So I have a question here from Gabriel J. Kraus. Thanks for the question, Gabriel. He asks, can you please explain the if Lipschitz then continuous more? This is at the 12-minute mark. Can you show me how you got your delta? So just to recap, let's go over our definitions again. So a continuous function. So for some subset A of Rn, we have some function that maps A to Rm and is continuous at a point A if for all epsilon greater than 0 there's a delta greater than 0 such that whenever the norm of x minus a is less than delta for some x in a, we have that the norm of fx minus fa is less than epsilon. So we just need to find if we can give a delta for any epsilon that satisfies this, then we get continuity at A, and we can just say a function is continuous if it is continuous for all A in A. Should be pretty basic definition there. Now let's recall what Lipschitz continuity is back at 12 minutes. So there a function, I'm just gonna skip the repeated parts, f from A to Rm, where A is a subset of Rn, a Lipschitz function if there's an m in R such that the norm of fx minus fy is less than or equal to the norm of x minus y for all xy in A. And we note that this m is going to be positive or non-negative, at least, since the norm will be non-negative. So for this to hold true, that has to be non-negative, because these are non-negative. Okay, so now to answer Gabriel's question, we want to prove Lipschitz functions are continuous. So let's go over the definitions. So let A be a subset of Rn, and let's have a function from A to Rm be Lipschitz. Since it's Lipschitz, we know that there is an m in R, and moreover that it's greater than or equal to 0 that satisfies norm of fx minus fy less than or equal to m times norm of x minus y. Now we want to prove that it's continuous. So let epsilon greater than 0 and delta equals, we don't know yet, so let's write that. Let x, y in A, and we're just going to show it's continuous at every point, so I'm just going to say it's continuous at y, at every y, such that norm of x minus y norm is less than delta. Okay. And now we want to show we have we now need to show that norm of fx minus fy, because we're using y here, is less than epsilon. So fx minus fy. We have this inequality, so we can just plug that in. X minus y is less than or equal to, so we know x minus y is less than delta, so we can plug delta in there. So just replace that, less than or equal to m delta. So now we need to show that it's less than epsilon. So we can just say it's is that right? Is it less than epsilon or less than or equal to? Oh, it's less than. Okay, less than epsilon. And we're going to say it's less than epsilon, and just make the delta and choose delta to be appropriately cancel out. So let's say let delta equals, if we go 1 over m, then that will give us m times 1 over m, which will give us 1, which isn't what we want. Let's say epsilon over m. So now this turns to an epsilon. Which still doesn't make it work. So let's go with epsilon minus 1. So that will give us epsilon minus 1, which is less than epsilon, which gives us what we need. Thus, f is continuous.